Section 6.1, graphing linear inequalities in two variables. So before we start this, I just want to take a second and look at how we would write or say these things in symbols. So first is greater than. So if I wanted to say 2 was greater than 1, you guys remember the alligator opening. Less than, greater than or equal to, less than or equal to, at most. Okay, this one's kind of difficult. If x is at most, it must mean, if x is at most 2, well, it could be 1, it could be negative 3. So we write x is less than or equal to 2. No more than would be the same thing. So this symbol. No less than is going to be greater than or equal to. At least, okay, if x is at least 2, it could be 3, it could be 7, same thing, greater than or equal to, is more than, if x is more than 2, x is fewer than 2. Okay, so these are some of these words. Take a second to realize what inequality you're writing, but if you just think about real numbers or real situations, it's usually easy to figure out what symbol to use. Okay. For which inequalities is 3, 1 a possible solution, and how do you know? So the way you figure this out is you just sub it in, okay? So 3 is x, 1 is y. Is 13 minus 3 times 3, because that's my x value, greater than 4 times 1? Is 13 minus 9 greater than 4? Is 4 greater than 4? No, doesn't work. Okay, 2y, so 2 times 1 minus 5, is that less than or equal to 3? Is 2 minus 5 less than or equal to 3? Is negative 3 less than or equal to 3? Yes. Okay, y plus x less than 10. So is 1 plus 3 less than 10? Is 4 less than 10? Yep. And is y greater than or equal to 9? Is 1 greater than or equal to 9? No. Okay, so these ones satisfy that inequality. Okay, next page. Amir owns a health food store. He's making a mixture of nuts and raisins to sell in bulk. His supplier charges $25 a kilogram for nuts and $8 a kilogram for raisins. What quantity of nuts and raisins can Amir mix together if he wants to spend less than $200? So, first of all, we're going to assume he wants to make exactly $200, and we need an equation. So, each kilogram of nuts is $25. So we can have 25x if we would have started with let x be a number of kilograms of nuts. That's where we should start. And let's let y equal kilograms of raisins. Okay, so each kilogram of nuts costs $25, and each kilogram of raisins is $8. So you go 25 times x, because each kilogram costs $25, plus 8 times y equals $200, if you wanted to spend only $200. Now it says, to what set of numbers does the domain and range of the two variables your equation belong? Use this information to help you graph the equation on a coordinate plane. Okay, so let's think about this for 1 second. Values of x and y. Can we have negative kilograms? Can you say I want to buy negative 3 kilograms of nuts? No. Can you buy half a kilogram? Yeah. Can you buy a third? Can you buy 0.23765? Yes. So x is going to be greater than 0, greater than or equal to 0, and y is also going to be greater than or equal to 0, and x and y are in the real numbers. They're any number, okay, any decimal. Number C, to what set of numbers? Use this information to help you graph the equation on a coordinate plane. And probably the easiest way to do this is to get the x and y intercept. So to get the x-intercept, we let y be 0. Okay. If 25x equals 200, x is going to equal 8. Okay, so we have a point at 8 and 0. Okay, so let's draw this graph, and I'm going to draw it like this. So x is equal to 8, y is 0. Okay, now let's do the y-intercept. We're going to let x be 0. So 25 times 0 plus 8 times y equals 200. 8y equals 200. Y equals 25. So we have the point 0 and 25. Uh-oh. I should have drawn this graph different. Okay, let's say we draw with our axes there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20. We're going to let each one be 2. So that's 8 and 0. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. Okay, so there's my intercepts. And I would draw this line. I would get a nice straight line there. Okay, that would be the graph of this equation. Okay, next it says, what region of the plane includes the points representing the quantities that he would use if he wants to spend less than 200? How do you know? So basically what he's saying is this graph kind of splits this in half. Are we talking about the region here or the region there if he wants to spend less than 200? Everything on the line is exactly 200, but if he wanted to spend less, is he talking about the area underneath or the area above? And the way I'm going to test out is I'm going to put a test point. I can do the test point 0 and 0. And if I subbed in a 0 here and a 0 there, would that be less than or equal to 200? Of course it would be. So we're talking about the region underneath. Okay, so we're actually talking about this region only right here. And now the important thing to notice is that I only filled in the part that was within the x and y axes. And the reason I did that is because remember we said that x and y were both greater than 0. If I would have colored in this point, I would assume that x could be less than 0. I would assume we could have negative kilograms of nuts. If I colored in this region under here, I could say, well, we have negative amount of raisins. And if I would have colored in there, it would have been negative raisins and negative nuts, which doesn't make sense. So I'm only coloring in that region if I want things that are less than or equal to $200. Okay. Is it represented? Oh, we already did that region. Why might you use a dashed line instead of a solid line? Okay, let's do some better reading. He wants to spend less than. So to show that it's not less than or equal to, what we would do is instead of having a solid line, we would actually make it a dotted line. And that would show that that's the boundary. We don't actually count those points, but it would be everything underneath that. Okay? So just some more practicing from graphing. We're going to graph the solution set for this linear inequality. Negative 2x plus 5y is greater than or equal to 10. So the first thing that I do is I just treat it as if it was equation. 2x plus 5y is equal to 10. And what I do is I find my x and y intercept. So let's find x intercept. What we do is we let y equal 0. If negative 2 times x equals 10, well, x must be negative 5. So I have the point negative 5 and 0. This time I'm going to get both points before I start plotting. Now I am going to get my y-intercept by letting my x be 0. So in this case, y would be 2. So we would get 0 and 2. Okay. So I have x equals 0, y equals 2, x equals negative 5, and y equals 0. So there is my points. So I'm going to draw the line. I notice that it's greater than or equal to, so it's going to be a solid line because that means include the line. And now I have to decide if I'm talking about the region above or below this line. And I'm going to choose a test point, and I often choose 0, 0 if I can because it's the easiest one. Well, is negative 2 times 0 plus 5 times 0 greater than or equal to 10? Is 0 greater than or equal to 10? No. So I'm not talking about this region. I must be talking about the region above. And I would shade that in. Okay, now comes the fun part. Okay, there's rules for shading, and this is something that you're going to want to either color photocopy or draw out because you can bring this into the exam. Okay, when a linear inequality in two variables is represented graphically, its boundary divides the Cartesian plane. It divides that xy set into two half planes. One of these represents the solution set of the linear inequality, which may or may not include the points on the boundary itself. Okay, so the steps, we graph it. If it includes, then we draw a solid green line to show that it's included. So I should have been drawing solid green lines. If it includes the possibility of equality and it's discrete, we're going to stipple the boundary with green points. So we're going to make the boundary and put a bunch of green points. Okay, things that are discrete are things like people, animals, number of desks. It's called discrete because you can only have one desk or one person or three people. You can't have 2.7 people or 2.3 desks. That's what it means to be discrete. It's like you're counting numbers, okay? Whereas continuous graphs means you could have 1.3, 1.32, 1.3337, so you could have all those decimals. Okay, if the linear inequality excludes, we draw a dashed line to show that the points are not included. Use a dashed green line for continuous sets, a dashed orange line for discrete. Okay, so this is the biggest headache is the coloring. Okay, then you choose a test point to decide which it is, and then you, if possible, always use that origin. If it's solution, then you shade that half plane. Okay, and they showed right here some coloring examples. So this one, they said X is a member of the reals, Y is a member of the reals. So that is all real numbers. It's shaded in green. Because there's that equals to, it's a solid line. Okay, this one, X and Y are real, so that's that solid green. But look, there's no equals to, so that's why they put the dots there. Okay, this part is like the best part to always refer to. Okay, in this one they have equality, but they say it's only integers. And that's another way of saying discrete. It's only counting numbers. You can only have 1, 3, 7. Okay, and so they shaded green and they also stippled. Or sorry, they shaded orange and they stippled green. So that's saying it's only these exact points that count. It's not everything else. Okay. So when you're practicing this, I wouldn't spend time coloring my entire graph the right color. I would just color a part of it to show, like this part you could shade in all green quickly. This part I would just shade a little bit in orange with a couple of dots just to show that you know the process. Okay, and then this one, there's no less than or equal to, it's just less than. So they show that with this line. And then the fact that it's discrete, the fact that it's integers, they show that. Okay, good idea to do lots of practice questions. Look in the back, there's a colored answer key that's going to help you out. And don't be afraid to ask me for help if you need it.